Hello Math 1010 students. So we're looking at complex fractions right now and simplifying complex fractions. There's two ways to do this. I'm going to show you method 1 right now, and depending on the time left on this video component, I may do method 2 on this component or on this video, or I may do it on a future video. Well, let's look at method 1. What method 1 does is it creates one fraction out of these two fractions, and then one fraction out of these two fractions, so that I can invert and multiply the bottom fractions. So what I'm going to do is I'm going to get one fraction with what I've got right here, this x plus 3 over x minus 4 over x minus 1. To do that, I need to get a common denominator. So I'm going to multiply top and bottom of this first fraction by x minus 1, and then top and bottom of the second fraction by x. As you can see, we're going to have a common denominator of an x times x minus 1 when I do that. Looking down here at this fraction, I'm going to be multiplying this first fraction top and bottom by the x minus 1, and the second fraction I'm going to multiply by an x. So as you can see, my common denominator there is also going to be x times x minus 1. It is a coincidence that my common denominator in this big numerator is the same thing as a common denominator in this denominator here. That won't always be the case, but it just kind of worked out that way on this problem. So, distributing here, first outers, inners, last, if you follow the FOIL technique, I've got x times x, that's x squared, and then x times negative 1, that's negative 1x, 3 times x, that's 3x. 3 times negative 1, that's negative 3. And that's all over x times x minus 1. Now, I've also got minus 4x. In fact, I'm going to go ahead and put that as part of this big numerator here. Now, looking downstairs, I've got x plus 1 times x minus 1, and if you are up to speed on your special case polynomials, that happens to be the difference of squares. So I'm going to write that as x squared minus 1, and then I get my plus sign, and then I've got x times the quantity of x plus 1, so I'll distribute that. That'll be x squared plus x, and that is all over x times the quantity of x minus 1. Now, I'm going to do two things on the next step here. I'm going to invert and multiply while I simplify at the same time. I hope that's not too big of a step for everybody. So I'm going to simplify this fraction right here first. When I do that, I'm going to have my x squared, and then I'm going to have my negative 1x plus 3x minus 4x. Let's see, what is that? That's going to be negative 5, negative 2x. And then I have my minus 3 there as well. And that's all going to be over x times x minus 1. Now, at the same time, I'm going to take this bottom fraction here, this guy, and I'm going to invert and multiply that as well. I'm going to invert and multiply it, and then I'm going to simplify it. So it'll flip over and multiply, so I'm going to have x times the quantity of x minus 1 on the numerator, and then in the denominator, x squared times x, or plus x squared will be 2x squared. And then I've got a plus x and a minus 1. Now, when we multiply fractions, you can do the simplification just as if it was all one fraction. So, my x will divide out, my x minus 1 will divide out. That'll leave me with x squared plus, or minus 2x minus 3 in the numerator. In the denominator, it'll leave me with 2x squared plus x minus 1. I'm going to go ahead and factor out my numerator. That'll be x minus 3 and x plus 1. That's what this guy is factored out. Now the 2x squared plus x minus 1, if we factor that, and there are techniques to factor, different techniques. I believe I showed you one already that's actually pretty handy. This one's actually pretty easy to do trial and error, I think, just because I've got a prime number of a 2 here, and then I've got one here that only has the factors of 1 and negative 1. So let's see, I've got, this will have to be a plus and this will have to be a minus. If we were to multiply this out, when you do the multiply this out, you'd have 2x times x is 2x squared, and then outers and inners would be 2x minus x would be a 1x that we see there, and of course negative 1 times positive 1 would be a negative 1 there. Now, as you can see, we're not quite done yet. We've got a little more reduction that's happening there, and then our answer is x minus 3 over 2x minus 1. Again, that is method 1. I'll show you what method 2 is. In fact, I'll probably do that right now. Give me just a second to my erasers across the room. So I'll go ahead and get this out now. When you use method 1 and method 2, is there a preferable time to do that? You know, it depends on you. You can do one, you can do the other one, it doesn't matter. Some people like to just go exclusively method 1. Some people like to go exclusively method 2. Some people, if you get pretty good at this, you could do them interchangeably, depending on the situation. But you need to be kind of forward thinking in terms of being able to see what you're going to be working with. So it really does boil down to your mathematical prowess, if you will, and how comfortable you are with working different problems. So what method 2 is, it's this. Instead of making one fraction here and one fraction here and then inverting and multiplying the bottom fraction after you make the one fraction on each top numerator and denominator, what you do is you look at all your little denominators here and you look at the LCD with what you've got there. In this case, it's x times x minus 1. And so what you do is you multiply each one of these little fractions. So I've got a little fraction here, and here, and here, and here. So 4 of them. I'm going to multiply all 4 of those little fractions by that LCD. So x times x minus 1 here, x times x minus 1 here, x times x minus 1 here, x times x minus 1 here. Alright, so let's see what we can get to divide out. My x's will drop out there, my x minus 1 will drop out there, and x will drop out there, and x minus 1 will drop out there. So the advantage of using method 2 is that you'll get things to clean up in a big hurry in terms of all these extra fractions, whereas method 1 you're stuck with fractions all the way through. However, method 1 might be more familiar to some. So here I go. I've got x plus 3. Let me switch colors actually. I've got x plus 3 times x minus 1 minus the 4x, all of that over x plus 1, x minus 1, plus this x times a quantity of x plus 1. So as you can see, I got rid of that extra fraction right away. So let's multiply this out. I'll have x squared minus x, or minus a 1x, plus a 3x minus 3, and then minus the 4x. That's my numerator. In the denominator, as you can see, I've got the difference of squares happening here again. So that'll be x squared minus 1. And then I'll distribute the x times the x plus 1 here. So plus x squared plus 1x. I'll go ahead and I'll simplify my like terms now. X squared, so here I've got a negative 1x plus 3x, that'll be 2x. 2x minus 4x is a negative 2x. And then my minus 3. All of that over 2x squared plus 1x minus 1. And I already factored this once, it'll factor nice. X minus 3 and x plus 1 for the numerator. And in the denominator, 2x minus 1 and x plus 1. And as you can see, the x plus 1's will drop out, leaving us with x minus 3 over 2x minus 1. So there's two, so that's method 2. There's two approaches, two methods to solving complex fractions. Which do you want to do? You know, it really depends on you. For those of you taking my class, we use my math lab, obviously. And if you were to hit view an example, it's going to show you probably method 2. Just so you know. Is it better than the other one? Not necessarily. It really does depend on you. So if you got any questions, give me a holler.